All right, today we're going to do something a little different. We're going to go behind the scenes and walk through a real-world disaster recovery project, step by step, from the perspective of the cloud architect who lived it. This isn't textbook theory. This is about the practical, sometimes messy reality of protecting a critical application on AWS. Let's dive in.
But first, let me just ask you this. Picture it. It's 2 in the morning. Your phone is lighting up with alerts. The main application, the one that makes all the money, is down, hard down. What do you do in that exact moment? Having a real, tested answer to that question is exactly what we're talking about today.
So, let's set the stage for our story. The mission was, on the surface, pretty simple. Bulletproof one of the company's most critical applications. The subtext, though, was crystal clear. Failure was not an option.
And here's where the challenge really came into focus. First off, this was the company's main e-commerce app, the revenue engine. The business flat out said they had zero tolerance for data loss. That one requirement alone puts you in a very specific box, technically. Of course, any outage would immediately impact thousands of customers. And to top it all off, this wasn't some simple website. It was a complex, multi-tiered beast with all these different web, application, and database layers that all had to work together perfectly. So yeah, this was going to be tricky.
So where do you even begin? Well, before we could even think about technology, before writing a single line of code, we had to do the single most important thing. We had to define what success actually looked like. In disaster recovery, that all comes down to 2 little acronyms. And here they are, RTO and RPO. They are the absolute foundation of any DR plan. RTO, Recovery Time Objective, is basically the stopwatch. It answers the question, how fast do we need to be back up and running? RPO, Recovery Point Objective, is all about the data. It answers, how much data are we willing to lose forever? Get these numbers wrong, and you either build something that's too slow for the business, or you spend a fortune on a system you don't actually need.
Okay, so after a lot of meetings and negotiations with the business leaders, we landed on our RTO, 4 hours. Now that might sound like a decent amount of time, but for a system this complex, that is a very ambitious goal. It meant from the second we declared disaster, we have a 4-hour countdown to get everything, every single piece of the app, back online and serving customers in a totally different region. And then came the RPO, just 15 minutes. Honestly, this was the real killer requirement. The business basically said we could not lose more than 15 minutes of customer data. Think about that. That's 15 minutes of orders, of new accounts, of activity. This single number dramatically changed the game and forced our hand on what technology we could even consider.
So now we had our marching orders, a 4-hour RTO and a 15-minute RPO. With those targets locked in, we could finally start making smart decisions about the actual architecture.
And in AWS, it really boils down to this classic trade-off you see here, speed versus cost. A simple backup and restore? Super cheap, but way too slow. No way it would meet a 4-hour RTO. Pilot Light? It's faster, getting warmer, but it was still cutting it a little too close for comfort. To confidently hit both of our aggressive targets, there was really only one choice, the warm standby pattern. It's more expensive for sure, but it was the only option that gave us the speed we needed.
So what is a warm standby? Think of it like this. You have a miniature version of your entire application running 24/7 in a separate location. It's fully functional, data is constantly flowing to it, but it's running on smaller, cheaper hardware just to save money. Then, when disaster strikes, the plan is to just flip a switch and scale it up to full production size.
And here's a quick peek under the hood at how we built it. To meet that insane 15-minute data loss window, we leaned heavily on AWS's database service, RDS, to constantly replicate our data across regions. We defined every server, every network, every single piece of the environment as code. That ensured our recovery site was a perfect, repeatable clone of production. And this is so important. We built a ton of automation, but we also wrote detailed, human-friendly runbooks because you never know when automation might fail.
So, we had the plan, we had the architecture, everything looked perfect. On paper. But as we all know, a plan that hasn't been tested is really just a theory. So it was time for the moment of truth, the part that makes everyone sweat. A full-scale disaster recovery drill. Okay, so the drill kicks off. We simulate a complete failure of our main region. Within seconds, alarms are going off. 5 minutes in, the automated scripts kick in, and our warm standby environment roars to life. 45 minutes into the drill, we're high-fiving. The database is live, services are up, we are absolutely crushing our 4-hour goal. And then,
At the hour-and-a-half mark, we hit a wall. The infrastructure is running perfectly, but nobody on the public internet can actually get to the application.
This quote from the postmortem really says it all. The team's plan for failing over the AWS infrastructure was flawless. It works like a dream. But we had a massive blind spot. We had completely forgotten to account for the time it would take our external DNS provider to update the world and tell everyone where the application's new home was. The infrastructure was ready to go, but the rest of the internet had no idea how to find it.
Now, it's easy to look at that and call the drill a failure, but actually, it was a huge success. Why? Because we discovered that critical flaw in a safe, controlled test, not during a real outage with the CEO breathing down our necks. So let's break down these hard-won lessons.
The number one lesson: you have to test the entire end-to-end flow, not just your servers, but all the external things you rely on, like DNS. Second, while automation is your best friend, you absolutely need a clear, calm, step-by-step guide for the humans to follow when things go wrong. Third, DNS update times, what we call propagation, can absolutely destroy your RTO. You have to account for it. And maybe the most important lesson of all: a drill is never pass-fail. It's a treasure hunt for finding your blind spots.
So what does all this mean for you? Well, here's a simple playbook. Step 1. Go talk to your business and get actual numbers for your RTO and RPO. Don't guess. Step 2. Let those numbers guide your choice of architecture. Step 3. Automate everything you possibly can, but document it like you have to do it by hand at 3 a.m. And finally, the most crucial step of all: drill. Find what's broken, fix it, document it, and then do it all over again.
So we've walked through our test, including the big surprise that almost tripped us up. It really forces you to ask a tough question. Your disaster recovery plan might look perfect on a whiteboard or in a document, but have you really put it through the fire? Is your plan ready for a real one?